So in the previous class we are discussing about the quantum numbers. So in the quantum numbers we are discussing about the principal quantum number. So in this class we are discussing about the which quantum number it is, the angular momentum quantum number. So this angular momentum quantum number also called as the azimuthal quantum number. So it is also called as which one? It is also called as the azimuthal quantum number. So it is also called as the subsidiary quantum number. It is also called as the subsidiary quantum number. So these are the names are given to the azimuthal quantum number. So the angular momentum quantum number. So this is also called as the azimuthal quantum number, and it is also called as the subsidiary quantum number. So the angular momentum quantum number having the integer values. So it is also having the integer values. So that integer values from the 0 to n minus 1. So it is having the values. The principal quantum number having the positive integer value. So positive integer value nothing but n is equal to 1, 2, 3 and so on. But in the azimuthal quantum number, angular momentum quantum number, the integer values, it is having the not positive we are saying. So it is having the integer values. So that values from the 0 to n minus 1 values. For each n value, L value represents. So L value represents one subshell. So for each one, for each the n value. So L value represents the which one? L value represents one subshell. So this L value. So L value represents the shape of the subshell. Shape of the particular subshell. Shape of the particular subshell in the space. So in the space around the nucleus. In the space around which one? So in the space around the nucleus. So L value. For each L value represents the which one? L value represents the one subshell. So L value represents the shape. L value represents the which one? Represents the shape of the particular subshell in the space which one? In the space around the nucleus. So for L value. So for the which one? For the L value, it will represent. So it will represent. For L value, it will represent the subshells in the letters. The subshells in the letters S, P, D and F, so on. For the which one? For the L value. So we will represent. For the L value, it will be represented by the which one? The subshells are represented by the letters. So what those are the letters? The letters are S, P, D and F. So here L value. So we are taking the L value, name of the subshell. So name of the which one? So name of the subshell. So we are writing here L value is 0, L value is 1, L value is 2 and L value is 3. So these are the values of L. L is equal to 0, 1, 2, 3. The name of the subshells are S, P, D and F. So these are the which one? For each L value, it will represent the subshell in the letters. The letters are represented by the which one? Represented by the S, P, D and F. So here L value is 0. The name of the subshell is S. So if the L value is 1, the name of the subshell is P. So if the L value is 2, the name of the subshell is D. If the L value is the 3, the name of the subshell is F. So if the N is equal to 1, so if the N is equal to 1, the subshell have only one value. So it is having how many values? It is having the only one value. So that L value is equal to 0. It is represents. It is designated by the oneness orbital. So it is designated by the designated by the oneness orbital. When the N is equal to 1, the subshell have the how many values? It is having only one value. So that value is L is equal to 0. So it is designated by the which orbital? It is designated by the oneness orbital. So like that. So if the N is equal to 2, the subshell having the how many values? It will having the 2 values. The subshell having the which one? How many values? It is having the 2 values. So that is L is equal to 0. It will be represented by the 2s orbital. So if the L is equal to 1, so it will represent the 2p orbital. So it will represent the which one? It will represent the 2p orbital. So if the N is equal to 2, the subshell having the how many values? It is having the 2 values. So what is the values? L is equal to 0. So it will represent the 2s orbital. If the L is equal to 1, it will represent the which one? It will represent the 2p orbital here. So that is if N is equal to 4. So for example, if N is equal to 4, the subshell having how many values? The subshell having the 4 values. So the subshell having the how many values? It is having the 4 values. So that is the L is equal to 0. It is represented by 4s orbital. L is equal to 1. It is represented by the 4p orbital. L is equal to 3. It is represent the 4d orbital. The L is equal to 3. It will represent the 4f orbital. So like this for N is equal to 4 value. So N is equal to 4 value. It is having the subshell having the how many values? It is having the 4 values. So that is the L is equal to 0. It is represented by the orbital 4s orbital. So if the L is equal to 1, it is represented by the 4p orbital. So if the L is equal to 2, it is represented by the 4d orbitals. So if the L is equal to 3, so it will represent the 4f orbital. So this is the class about the angular momentum quantum number. So this angular momentum quantum number also called as a which one? Azimuthal quantum number, or it is also called as the subsidiary quantum number. So one point we are forgetting that. So it is introduced by the Sommerfeld. It is introduced by the scientist. Who is that scientist? Sommerfeld. So this azimuthal quantum number having the how many values? It is having the integer values. That integer values from 0 to n minus 1. So for each n value, L value represents the which one? L value represents the one subshell. For how many values for the each n value? L value represents the one subshell. So if the L value represents the which one? It will represent the shape of the particular subshell. So the L value represents the shape of the particular subshell in the space around the which one? In the space around the nucleus. So if the L value, it will present on the which one? Present in the subshell in the letters. So it is represented by the letters. So that is the S, P, D and F. So the L value, so it will present. So the L value, it will represent the which one? It will represent the subshells in the letters. How it is represents this L value in the letters are S, P, D, F. So that is L value is equal to 0, the name of the subshell is S. If the L value is equal to 1, the name of the subshell is P. The L is equal to 2, name of the subshell is D. If the L is equal to 3, the name of the subshell is F. So here the N is equal to 1. The subshell having how many values? It is having only one value. What is that value? N is equal to 0. So it is designated by the which orbital? 1s orbital. So if the N is equal to 2, the subshell having the how many values? 2 values. So that is the L is equal to 0, designated by the 2s orbital. L is equal to 1, it is designated by the 2p orbital. If the n is equal to 4, so the subshell having the how many values? It is having the 4 values, that is L is equal to 0, 4s orbital, L is equal to 1, 4p orbital, L is equal to 2, 4d orbital, L is equal to 3, 4f orbital. So this is the information about the angular momentum quantum number. So in the next class, so we are discussing about the magnetic quantum number.